Okay, I'm not going to do the next problem. It's kind of a combination of the previous two problems, so I'm going to let y'all work on that. And it says, one of the problems says, Tasha used a clever method to expand a plus b plus c times a plus b minus c. She grouped the add-ins together where she grouped a plus b in both of those parentheses and then had plus and minus c. And then expanded them to get the difference of two squares. Okay, so what it says is she had a plus b plus c times a plus b minus c. She groups them and says, okay, those are common, so I'm going to group those together. Then she writes it out as that would equal a plus b squared minus c squared. And that would equal, what she says here is now I have a difference of two squares, right? So that's going to be a squared plus 2ab plus b squared. And then she has minus c squared. Okay. And it says, is she correct? And yes, she is correct. So now then, the next one says, use a version of her method to find, and then they say a plus b plus c times a minus b minus c. Okay. So how would you go about grouping these? Well, if we group these together, I need to be a little bit more specific on that parentheses there so that you know if it's included in that negative or not. Minus, okay. So if we group the b plus c and the b minus c, now what we have are a squared minus, okay, because if you were to multiply a negative b minus c times a b plus c, you'd have a minus b minus c squared. So you'd have a difference of two squares, okay? And then right here, you also have a difference of two squares for the b and the minus c. So what ends up happening is you have your a squared minus b squared minus 2b squared minus c squared. And that's just if you were to break this out into b minus c times b minus c, okay, that's b squared. It's negative because it's inside the parentheses. So this would become a negative b squared, and then you'd have a negative b c times a negative bc. Okay, and that would be a positive 2bc, but the negative negates it, so it becomes a negative 2bc. And then you have your negative c times negative c, which is c squared, and then this negative right here is what's negating all of those. So there is your answer. I don't think we can combine anything. Yeah, that's it for that one. And then I think it says, and it gives you another trinomial times trinomial, and it asks you to do the same thing. Just group them and try and answer that one. Okay. The next problem that it gets to is just, it wants you to write the two square identities. What we were doing there was talking about the square identity. to factors of each of the following expressions. So the first one's easy. We have x squared minus 81. Now it's easy because we know that's going to make conjugates. And we'll have x and 9, x and 9. And that's your answer. Now, if we come over here and do the next one, it's where it gets a little bit tricky. I can't write a y. Here we go. Whoa, that's all squared. And it's minus 2y. And that's all squared. Okay. So now we know that we have the difference of two squares. So if we have the difference of two squares, what I would tell you to do, especially for this first one, is just work it out and solve it. Okay, and what I mean by that is just go ahead and say 3x plus y times 3x plus y minus 2y times 2y. And then let's see what happens here. Okay, this would be 9x squared plus, and then we'd have first outer and inner. Okay, so that's going to be 3xy plus 3xy, which is going to be 6xy plus y squared minus, and this is going to be 4y squared. Okay, so if we combine like terms, we have these y squares. We have 9x squared plus 6xy minus 3y squared. Now, we can break this apart and we can factor out a 3 from all of it. Because it's x squared plus 2xy minus y squared. Okay, now hopefully you would recognize this. Oh, this would be 3x squared. Okay, now you have to say, can I break that down anymore? Can I factor this trinomial? And yes, you can. That's going to break up and be 3x let's see here, minus y and x plus y. So you'd have to leave your 3 out front there. 3x times x is 3x squared. Your last one's going to be negative y times y, which is going to be a negative y squared. And then if you do the outer, that's 3xy. The inner is negative xy, which leaves you with 2xy. So the answer is going to be 3 times 3x minus y plus x plus y. Now that's the very, very, very long way of doing that. Okay, now, but I wanted to show you how it's actually going to work. Now, I want to show you how to do it using the two squares identity of factoring. Okay, so I'm going to erase this all. And this one, all you have to really worry about is your squares, your signs. Okay, if you will write it down like kind of as a template and just fill in the numbers, it should help. Okay, so let me rewrite the problem. 3x plus y. Y does not want to work, and all that is squared minus 2y, and all that's squared. Now that we've got that, we should notice that it's the difference of two squares, okay? And the difference of two squares creates conjugates, okay? Conjugates is going to be a plus and a minus. Now, you have to say, what is going to be our first term? Well, our first term, this is what we used to refer to as x, right? This first term is what we refer to as x, okay? So we got 3x and we're going to have 3x here, okay? Now, since we have, we're not done yet, so we're going to have our plus y, all right? And let me give myself enough room in here. So let me go back here. And here it is. Over here. So plus y, and this is going to be plus y. Then this is where it negates. We have 2y, not negates, but we have a conjugate minus 2y. Okay. Now what you would do there is say 3x, and here we're going to have plus 3y, and here we'd have 3x minus y. If you combine these y's here, that's 3x. This is just a negative y. Hopefully you're all noticing that. Now, here's what they're going to say. Remember we had that 3 on the outside of the parentheses earlier when we factored everything out, because we could factor a 3 out. Well, we can still factor a 3 out here. Okay, so let's go ahead and factor a 3 out of this, and that leaves us with x plus y. And then we still have a 3x minus y over here, and we're just going to leave that there. We don't want to mess with that 3 in there because you can't actually factor it out of that term. So this is what you're left with, and it doesn't matter if you write these backwards or not, because multiplication is, the multiplication of commutative property of multiplication. So it don't matter if we write the 3x minus y first or 3x plus y. So don't get hung up on if you've done it backwards. That's all fine. All right. So I think we need to definitely do another one of those using the shortcut with identity. Okay, and this one looks a little bit weird. This looks kind of like, I don't know if you remember, I don't know, the first day of class I had some formulas right up on the board, and this was called the I had the Vertex Formula. This kind of looks like the Vertex Formula. My pen starts going crazy here. So 4 minus x minus 1 squared. Okay, now hopefully you look at this and say, okay, perfect. I have the difference of two squares. So this is a square, and I know this is a square because of my exponent there. And I know it's the difference because I got the subtraction there. So we're just going to write it out again. Remember, just keep it in order. You're going to have a negative and a positive because of the conjugates. So we can go ahead and write down what we used to refer to as our x, which is the first term, 2, because we would have to do the square root of that because we need it squared. So 2 times 2 is going to give us the 4. Now, the second term is just simply the x minus 1, but you have to watch out for the negation. Here, it's fine because it's our plus. So we can just write it down. Now here, we have to change it. It's going to be minus x plus 1, because you have to negate everything inside of it. So what it actually looks like is this. If you were to just okay, that's what it looks like. So that becomes a negative x. This becomes a positive 1, and then we can leave it like this, which it don't matter. That plus is mute at this point. Doesn't really matter. So now what we would have to do is, let's see here. I guess just combine my terms. Here we would have, I'm going to write it. I like the x's first. I'm going to put my x over here and say 2 minus 1 is plus 1. I combine these two terms. And same thing here. I want to combine these two terms. And I'm going to have negative x plus 3. Now they're probably not going to write it like that, because they're not going to want this negative here. So what they probably did is said 1 plus x and 3 minus x, which is the same thing. Doesn't matter. We can do that. It's probably the way they did it though. Okay. And then you have one more, and I know I'm giving y'all kind of the harder ones to do, as I'm showing you the easier ones, and then I hope you're able to follow the logic for the next one. I'll go ahead and do it with you though. Let me do this last one here. They're not the last one, but the last one in this set. Okay, so you have difference of two squares. Difference, two squares. Just remember this like your x and your a. So I bet my conjugates need to be a little bit bigger than that. Stuff is not going to work right now. Okay, sorry, I can't get it to work. Get rid of that parentheses. All right, where was I at? Conjugates. Okay, so let's go with plus. I can get anything to work here. And then this is going to be the minus. So I'm going to have to negate this. We have x plus x plus. Stuff's not working again, guys. Sorry. Just say x plus 2. Well, I can't get it to work. Okay, maybe I got it to work now. Oh my goodness, why is that so wide? What is going on? Okay. X plus 2 squared minus y plus 2 squared. Okay, now we got the difference of two squares. We see that. So we're going to have conjugates. So one's going to be plus and one's going to be minus. This is kind of like our x. This is kind of like our a. So x plus 2 plus y plus 2. Now here we're going to have x plus 2 and just put it in parentheses again, and then we can work it out. Okay, so this is x plus 2 minus y minus 2. And this is just our regular term here. Now we got to combine some like terms. So we'd have x plus y plus 4, x minus y. That's it, because these are going to cancel. And that's all we can do. That's it. It's not hard. As long as you learn that, y'all know that the difference of two squares is conjugates. And so if you'll recognize those, this will be much, much, much easier. Now, I know we started out going, well, why are we doing this? Because we were started out talking about the Pythagorean triples, okay? And that's what pretty much the rest of the lesson is going to be about, okay? So I'm going to actually wait and hopefully do another video on that because I need to draw. I can go and do it. Let's go and do it. I was going to try and put the chart in here. I'm skipping a few questions, but I'm going to try and just draw the chart because my drawing abilities are fantastic. So. That's 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, and 7, 8. How many columns do I need? 6. Okay. Now let's go ahead and start filling this in. All right, so this is going to be x, this is going to be y, x squared minus y squared. This is going to be 2xy. This will be x squared plus y squared. And this is going to be checking for Pythag triples. Okay. So the first one I think is supposed to be done for you. It's 2, 1. If we do that, we get 3. Do that, we get 4. Do that, we get 5. And so yes, 3 squared plus 4 squared equals 25, which is equal to 5 squared. Okay, now the next x's and y's, they have 3 and 1, 3 and 2, 4 and 1, 4 and 2, 4 and 3, 5 and 1. So if we said x squared minus y squared, that's going to be 9 minus 1, which is 8. 2x is just going to be 2 times 3, which is 6, because the times 1 doesn't matter. And then 2 times 3 is 6. Oh, no, here we are. X squared. That's going to be 9. Y squared is 1. So x and y squared adding would be 10. Now, what I have to say, does that, to check and see if that's a Pythagorean triple, 8 squared plus 6 squared equals 100. And yes, it does. That is 10 squared. So that is a Pythagorean triple, because all those are squared. All right, so let's do 3 and 2. 3 squared is 9 minus 4 is 5. 2 times 3 is 6, times 2 is 12. 2 squared, I'm sorry, 3 squared is 9, plus 2 squared, which is 4, is 13. 5, 12, 13. So let's see, 5 squared plus 12 squared equals 169, which is equal to 13 squared. So, yep, all those check out. Okay, and so that's what you'll do for the rest of those to see if you're checking Pythagorean triples. And that should just about get you down until the very last problem is more of a geometry, showing how they came up with the proof. And so we may do it during class one day or something. But anyway, there you go. There's another video for y'all. Hope that helps.